I've shared the data. Okay, so we have to continue with a new notebook and soft clustering with the Hdbscan. We have to see, and we have to see what soft clustering is, and basically we're implementing it on a data set we have. So we are using soft clustering for Hdbscan. So we know that the hard clustering is like you assigned some values, you have some mixed memberships there, and you assign a data set to a cluster depending on the cluster each assign you the point it is assigned, the cluster is assigned according to that you assign to a cluster or to noise. But in a soft clustering, it is actually the probability, based on the probability, that is a probability is assigned to a node, cluster, point, data point, you can say that. And that is also known as a fuzzy clustering. Fuzzy is nothing but probability only, if else and all. So we have to see how it works and how it works in uh, soft clustering. That means we need the prediction here, because we are talking about probability, then we need the prediction here. So we'll install a dataset. I have already downloaded that, so I have to import that. And uh, yeah, where is that? Okay, so here you are. So I have to download, that is, sorry, upload here. So we can upload any data set we want. So that data is something like NPY, clusterable data, NPY, that which I was trying to import last time, but I could not find it. Now I have found the data, and let me see if I can see something in this. If it is, no, you can see that it is more numpy types, so I can't see much points and all. Let's see if it can be used, and how it behaves. But we have other formats also of this data set. So first of all, we have to import the modules like Hdbscan, NumPy, Matplot, Seaborn, Tandas, and Matplot again. We have the PyPlot and the MPL. Then we have Skippy, spatial distance. We are finding the distance. So we have a Skippy dot spatial distance. We have to import C distance, C dist. Okay. So that is what is required. Then we have the plots we can have, and let's see, uh, we'll be importing the data and trying to plot the data, although it was more like a coded data, so it is not binary. It may be a binary form, or the format may be different. Looks like a Python data. But anyway, so we have clusterable data.numpy, the modules we have imported. Then we are trying to display something using Seaborn, plotting like poster. And then we have the white context is poster, style is white. Then we have the color codes. Then the plot keywords alpha 0.25 is 60, line width is 0. Palette, color palette, we have deep and 12. Then we are loading a combustible data, and then trying to plot it. Subplot 111, very commonly used in MATLAB also. This is the figure basically, so you get this thing. So the data is visible now, and this you can have you can change that also. The three-dimensional, like if you want this is 111, that is one figure you want to have. If you have sub plots, then you can change this value also. Even without this you can simply plot. But here creating an axis with subplot. So suppose you want to have some more plots in that. So 112, 113, and so on. You can have. Depends actually. We have different values. Now we have the cluster as we always do, and we have put the data, that is fit the data. We have created the object and fit the data also at the same time. So we can do that also. Now we will plot this cluster and see the data we have created. So we have to create this, and cluster labels and cluster probabilities we have to find, and we have to put the labels and the probabilities together. Here we have 1 minute. Let me put it in one line and take lines to go down. has okay. The cluster, we are creating an object and we have fit the data. Then palette, we have some color palette, we have deep, this is 8, the color changes, depth is 8. Then color, we have this SNS dot and then we have sat palette color is there. Okay. Mm. Desaturate, SNS dot desaturate pal, that is palette color. And then we have that is sat. Okay, now this is a for loop for call sat in zip. You're zipping the files, so you're clustering it. That is, you're bringing cluster labels and probabilities together, so you can have the cluster label and cluster probabilities. We have can do this. What we can do is we can display this first, and then we can plot it so that it makes more sense. So let me cut it from here and let me run this first. I should not be running the entire thing. You can see the probabilities, and if you want to see the labels, you can see the labels also. And let me put the labels also. I have to cut it. I'll just put it here. See the labels 5 5 minus 1, that means something is out of the cluster. Minus 1, that means it is not in the cluster. So we have 0 to 5, minus 1 to 5, and we have minus here, so that is something is not in the cluster, that is something out of the data, that is not matching at all. Okay, so you can have this like this. The colors are different. You can see the clusters, the values minus 5, we can have some minus values here, so they are not actually related, you can say that, but anyway, doesn't matter. So if you have a data point and we want to get a notion of how close it is to each of the cluster, there are there are at least two ways we can think about this. The first approach is to take the question somewhat literally and consider the distance from the cluster. That is, we have to find the distance from the cluster. That is what it has been created. You can see that the colors together, clusters together. Okay, and then uh, we can it can be seen in our example also, how the clusters are together. And the second way of looking at the thing is to consider how much of an outlier the point is relative to each other cluster. Outlier is something outside. Okay, we have something so score methods like glosh. Okay, we have outlier score from glosh, we can have that, and then we can calculate. Then we have the distance based membership also, we can create that, and for that we can create a function, and then we can see if this works for me. And we have the code already, so we just have to put it together. So distance based membership, so first of all we have to build a vector for pure distance based vectors of possible cluster membership. Okay, uh, okay, so for which cluster I am closer to. This is what when one cluster asks the other, okay, which cluster I'm closer to, or which data point asks that which cluster it is closer to. You can say like that. Okay, so distance, that is important, and we can create a function, or we can see it, call it an exemplar. So all the data points together, we can combine all the data points together, and we call it exemplar. We can have the lambda function also, the maximum lambda value, and we have to find the maximum lambda value in the leaf. Okay, so we have to find the we have to get the leaf cluster beneath a given cluster. Okay, leaf is just a sub part, you can say. Like we have a tree, we have the branches, and then we have the leaf. So that you can say. So we'll just and just copy paste. We don't have much time, so just paste. But I'll have to put everything together. So we can put the exam, we can plot the examplers, so we can you can get a sense of what points are being pulled out as examplers for each cluster. Okay. Okay, so let's do it. Let me plot it. And yeah, so you can see that the points which are outside, you can see with the points which we can take as examplers. Okay, so we have several leaves in action. You can see the leaves there, and the red and the cyan clusters having several subclusters. You can see that the red and the cyan have subclusters. Okay, 1 minute, I have to take the call. Okay, I'm just putting few things here. Exemplar, I'll just put so that you can don't have to go to the documentation and see what it is. Oh, I hope it is recording. Okay, so I'm just putting things here so that you don't have to go to the documentation and check what it is. So distance-based membership, I was just putting that. Okay, now you can see that the leaves are there and cyan and all. You can see that there are sub leaves also, although it looks very small, but it is visible. Okay, now we have defined already and we have plotted already. We can have compute the cluster membership. We can compute that also, and we have to compute for that. We can use few more functions, and just putting again the data, sorry, the code. The minimum distance to exemplar, then distance vector, then membership vector. These are the functions which are created. These are the calculations are there. So I'm just putting it as it is, and then we have to again plot it and see. I'm just giving you an overview, so you don't, it's not necessary that you understand the code. It is just an overview how Hdbscan works. Otherwise we can actually have it on a real data set also. This is a real data set only, but in your case you can have your own data set and then you can plot it also, but you don't need all this This is actually for distance-based clustering and all if you want to do that. Okay, and we can have the outlier also, outlier based membership also, and here is the, sorry, I used the wrong thing. I have to put the text here. Okay, this is all from the documentation only, so nothing like. So we can see that this is something that is step in right direction. You can see. Okay. Uh, uh, Now there can be some loopholes or main faults. We can have, like, suppose the example, there is spillover between the cyan and the yellow cluster. You can see that there is a spillover, yeah, and cyan and the green, basically more of the green. You can say the cyan and all mixing together, and this is because we are using pure distance, okay, and latching on whatever is the closest. So we are trying to find out whatever is the closest. So we are doing that. We have not found the outliers. So we can have the outlier based membership also, and we can get a better result that way. Okay, so we can separate that, and outlier based membership we can have, and we can have the data more clearly. Just putting this example for you. This is just an example, so you don't have to bother about things. Just have to understand that why the clustering is important and how the clustering behaves. Okay, so outlier is the what is not matching. Okay, so what is outside should be marked outside. Here there is a spillover, but in our case now there won't be any. So we are just defining some methods. And you must be wondering why I'm doing that. It's just to give you an example, an overview. So I'm just copy pasting, nothing else. I'm not doing anything else. But when I'll use my own data, I'll be or my own functions, then I'll be doing that on my own. So I won't be using all this. Not required for me. Okay. Uh, Result. We can return the result, and then we can call them. So these are the functions which have been created. We can call them. Outlier we are calculating basically, and then we are putting entire code together. These are the functions. So it looks like a long code, but we have the lambda value. We have to find the lambda value, then points and clusters, then merge heights. Then we have points in the clusters. Then we have to merge also. Then we have the cluster scores, and then outlier membership vectors. We have to find that, and then we are just plotting it. Looks little complicated, more mathematical. That's why I'm not going into it. But if you want the details, you can always have a look at the content I have already pasted here. Okay, so and the link you already have. So what it is giving me is similar to what it was, but it should not. But, let me see what happened. This looks similar, but it is not actually. Let me see. Oh, it just closed that. I wanted to expand it actually and see. The plot looks similar, but the color is cyan. If you expand it, you will see. I don't know how we can expand it. This will only close it. I don't know. I can copy this image and paste it somewhere and expand it and see the difference. Otherwise, the distance you can't see much. Then we have other things also. We can have the probability, the middle way, in a lot of things you can do. You can then you can actually combine the two approaches. Okay, that is what you can do. That is called the middle way. We can combine the two approaches and then arrange the data. Although in here they all look same, but when you will paste it somewhere, then you can have a look at it and then you can clearly see the difference. Here it looks similar, but it is not actually. So let's try to combine it. Two approaches, that is the distance and the outlier approach, and you can have a plot and see. Let's see how we can have a expand that. I think pie charm you can get a better output because there you have a different window. Okay, so we are combining this, and you can see now here you can see the difference. You can see the colors clearly. They're combining the two methods, the two approaches, and then we have to. So this is much closer to what we should get. Okay. And we have to convert conditional probability we have. So we'll find the probability. Converting a conditional probability that is required to get better results, better clusters. If there's a formulation there, so we'll put the formulation later, the probability we have to find, and then for this we are just putting the uh, function, which is already there, and I'll plot it and see. This is just to show you the difference between the things, what clustering could do. You don't have to master this code, and you may not be requiring this code at all. Okay, so we can have a better result. We can find the probability. So the result is that we merely need to multiply or combine membership vectors to get a vector of probability of being in a cluster, and we can visualize the results again. I'll just put it here. Okay, so anyway, let me see if I can put it somewhere and show you something better. Let me copy this image and let me put it somewhere and see if I can get a better look. This is a very small thing, and this may not show me exactly what it is. So let's see if I can get it. Oh, I can get this. I have pasted on Word, so you may not be able to see what I'm doing because I've not shared that. But I think we can have a better look at it somehow. You can also do that. You can paste it in a Word file and share it. I'll try to share this with you, but I don't think it is still very clear. But anyway, let me share it. Let me share the Word file where I have pasted the data, and you can also do this. What you can do is, yeah, there you are. So what you can do is, let me see, yeah, something like this. What you can do is, you can paste all the outputs. Let me have a look here. You can paste all the outputs here in a Word file and see the difference. Okay. This is just to understand clustering. You can see the clusters here and the leaves here. You can see the leaves here and the clusters. You can see that how the data is clusters. So outlier, then distance, and all probability we have to find. Then soft clustering we are doing. We are trying to see if it is not overlapping or just spilling over. You have to see that like this. If the data spills over, then that means it is going into the other cluster also, and some are very perfectly mapped, and there are these are the values which are in minus. That means they are not a part of the cluster. They can always be dropped or ignored. So the values are from minus 0.5 to my 0.5. So this is what it is, and you can see that any value which is in minus is not a part of the cluster. Okay, that we have already seen. So we can always get rid of that such data. Also, we can try with some more parameters. We can change the parameters and see. And let me go back to the code and just have a review of the code. Although this is just a simple copy paste from the document, but still you don't have to try to understand the code right now. It's not required. You just have to see the application. So going back, so we are just installing that. We have the soft clustering. We have to see that is also known as fuzzy clustering. Then with the Hdbscan, we are just calling the modules, calling the data, we are plotting it. You can see that there's no clustering here. Okay, clustering is there, but you can see that no leaves are there, but not marked. Okay, the probability types and all. Then we have something like this. We have then that is the data. Then we have the distance based membership. And we are trying to see how they behave. The leaves are there, and then we have exemplar. You can see more clearly. Then outlier based membership approach is there, so that is also plotted. So we have a Glosh algorithm, and based on that, the data or the outlier scores are arranged via this. Actually, Glosh algorithm this provides the outlier scores, right? And based on the score, the data can be arranged. Okay. So actually, we find the closest cluster in the condensed tree, and then compare how long the point stayed in that cluster with the total persistence of the heart of the cluster. Okay, heart is the center of the clusters of a cluster. Okay, of not the entire plot. We are talking about a cluster. So if you have 10 clusters, so heart of one cluster will be different from that of the other. That is the central point. One cluster would be different from the other. So this is what the function is all about. All the functions together, and then we plot it. Okay, and then finally what we can do is we can combine them, middle way, that is called the middle way, combine them and get the better plotting or the better probability. You can use probability also to find better match, better score, better clustering. Okay, so more of that data. You can see the data is getting closer and clearer. You can plot it in a Word file, all the plots. I'll share it with you, and then you can plot it, put it in a Word file and see the difference. You can actually expand it there, and the data will be clearer there. Here the plots are a little small, or even if you are using PyCharm, then the figures will pop up. You can do that, but we are using subplots, so the output may not be very clear. But anyway, you should understand what clustering is. Basically arranging the data together with the, suppose, the liking of a product, okay, or the purchasing of the product from the purchasing habits, like we started with the example, same way. So this can give you an idea about clustering, and the codes you don't have to worry about. I'll share it with you now. So